All right, so welcome everyone to my simple data encryption workshop. So to start off, I'm just gonna give some background information about what data encryption is, and then we'll go a little bit deeper into some really cool stuff that I found out about during my research on data encryption. So as we might already all be aware, our society runs on data exchange. So this data can be sensitive, intellectual, or used for some type of financial gain. We constantly engage in this exchange of information while performing tasks such as navigating the internet, which is, as we might already know already, is an open and public system where we all send and receive information through shared wires and connections. So even though it is a public system, we still exchange a lot of private data, such as bank information, passwords, and emails. So after hearing this, you might start to ask yourself, how is all this private stuff kept a secret? And well, this question can be answered through the study of cryptography, which is what I'm going to go on next. So cryptography is derived from the Greek word crypto, which means hidden or secret. And it is the study of techniques related to encryption and decryption, which we'll learn about in the next slides. So cryptography allows us to have confidentiality of data, meaning keeping data a secret, authentication and access control. That is, we can maintain certain information a secret and determine someone is who they say they are. Non-repudiation, which is another nice feature that allows us not only to authenticate where the source of data came from, but also to make sure that it is actually written by said source. And lastly, cryptography lets us check the integrity. This is to ensure that content has not been altered or tampered with since the moment it was sent to us. So how is this done? There are 3 steps in the process of encrypting data. So the process of cryptography begins with the use of plain text. So we might all be familiar with plain text, and if you're not, this is the original message before it undergoes any type of cryptographic changes. So this is otherwise known as an unencrypted message. During the second phase of encryption, we refer to ciphertext as information that has already gone through an encryption process. To be able to get the plain text to the ciphertext and back again, you need a cipher, also known as a key. This is the algorithm that is used to encrypt the plain text, and it's the algorithm that is used to decrypt the ciphertext as well. So the methods used to crack any type of encryption on data are known as cryptanalysis, which is a deeper study into the science of encryption. So encryption itself, when we are speaking about encryption, there are 2 important characteristics that encryption relies on. These are confusion and diffusion. So confusion means that the data that we have encrypted looks drastically different from the plain text that we began with. So there shouldn't be any patterns, and there should be no way to recognize any part of the plain text by simply looking at the ciphertext. So the characteristic of diffusion means that if we change one character of this plain text input, the ciphertext will be very different. And lastly, the most important component in encryption is the key, as we previously mentioned. So this is a secret password used for the unlocking and encrypted message. And it is also used to make sure that only the intended receiver has access to this message. So an example of encryption is the Caesar cipher, which is named after Julius Caesar, a Roman general, who encrypted his military commands to make sure that if one of his messages was intercepted by enemy troops, they wouldn't be able to understand it. So this is now a well-known algorithm that we might be familiar with. So this algorithm substitutes each letter in a message by another letter and by a certain number of steps down or up in the alphabet. So in this algorithm, the key is the number of steps. And if the receiver knows the key, they can decrypt the message by reversing the process. Obviously, this cipher is pretty simple to crack. Even if you don't have the key, there's only 26 characters in the English alphabet, meaning you would only need to try at most 26 keys to decrypt this message. So one way to improve this algorithm could be to either shift each letter by a different number of steps or some other techniques. However, obviously, computers could still very effortlessly run through billions of possible combinations to decrypt this key and successfully decrypt the message. So the solution to this problem is to increase the standard key length, which I will touch on later on. But this will essentially increase exponentially the number of possible combinations that it takes to crack a cipher. And as computers get faster and faster, we need to keep increasing the standard key length. So as of now, the best, I guess, the standard key length for the speed of computers nowadays is 256 bits. And I put a little chart, which is really interesting on the side, that kind of gives you a visual of how many possible combinations each one of the bits that we had in the past contained. So if we dig a little deeper into encryption, there are two modes of encryption methods. So one is symmetric and one is asymmetric. So symmetric is when the sender and receiver share the same key. A same secret key is shared between the sender and the receiver while performing encryption and decryption. This technique is best used for one-to-one sharing in smaller data sets. This means that if the key gets out, you'll need to get another key. Due to all of these security challenges that it poses, it is not a very ideal technique, but it is still used nowadays because it's very fast, and since it utilizes very few resources compared to asymmetric, some people will still use this. Now, asymmetric encryption, also referred to as a public key cryptography, it is composed of one public key that can be exchanged with anybody and a private key that is not shared. So the encryption key is public and can be used by anyone to encrypt a message. The opposite key is kept secret and it's only used to decrypt messages. So the public key basically allows others to send you data in an encrypted form, and the private key is the only way to decrypt that data. So most importantly, something very fascinating about asymmetric encryption is that public key cryptography is the foundation of all secure data exchange on the open internet. So when we send messages and such through the internet, we're using asymmetric encryption. So I stumble upon a couple of activities that kind of touch on the topic of encryption. And essentially, I have one that I can show you guys very quickly, and here's some on the side that you can try on your own as well. And there's a link to my GitHub as well, so you can pull up some of the documents that I'm going to use right now. Let me try to figure out how I can show you guys my Python script. Might take a little while. Okay. I don't know if you guys can see this.
Yeah, we can see it.
Okay. Okay, so this is essentially some really basic code that I pulled up from the Python open source system. So this is actually part of the Python library, and this component is called Fernet, and it's basically a symmetric encryption method, which makes sure that the message encrypted cannot be manipulated or read without a key. So this is a very fun piece of code that you can run on your own, and you can play around with the password and play around with the value. And essentially, when you run this module on a Python shell, you will, let me see if I can show you guys this. Here, I'm gonna share my Python shell. And by the way, I'm using Python 2.7. Yeah, so after I ran my script, my module, this is what I got. And so this piece of code is creating a key, and it's also creating a cipher and including a timestamp, which is pretty neat. And so with this, you can try to, I don't know, maybe try to decipher the key, using the key, the message, and you can play around with the message as well. I just thought it was pretty neat. Really shows you what goes into the whole process of encryption. Although this is, like we mentioned before, the easier type of encryption, symmetric encryption. On my PowerPoint slide, I also added another link which has, yeah, so it has more activities that deal with asymmetric encryption if you're interested in learning that. Of course, asymmetric encryption has a lot more components than symmetric encryption. I haven't played with those a lot yet, but they sound pretty interesting. Also, if you're interested in the Python component of encryption or cryptography, you can install it, and I have added an installation tutorial for that. So yeah, that's pretty much all I have for this workshop. Thank you.